Okay. Yes, got it. Okay, so we are here we are live from the moon. Actually, we are in the Space Business Innovation Center close to ESTEC in Norway. Yes, okay, yes, you make the right after. And of course, because this talk for our EHTOS community is about space research and workforce development, we have brought here a whole set of actors involved in research, and they are training actually in our program. Our program is Eurospace Academy, Euromoon Mars, and Space Renaissance. They are the Space Renaissance generation from Nordwijk today, and they are going also to present. So this time they are going to do the work. So I will do a 30-minute overview presentation on space for all and research and workforce development. And then each of them will have 4 minutes to present their ongoing research and activities. Is that okay with you, Ganim and Adriano, and all the team?
Excellent.
Yes.
Thank you very much.
Okay. So, Adriano, and Ganim, you want to say a few words before I start?
Yes, I would like to say something. Actually, this is our third webinar actually in our series, and we are doing this webinar series for as a preparation for our event that will be held in September, expanding humanity to outer space, international cooperation, and we will be happy, of course, to have a competition among teams from around the world. The winning team will win a partial scholarship to attend IAC 2025. So yeah, that's what we and those webinars are educational materials. I hope we will record them, and of course it will be for the reference of the teams in September. So Bernard, the floor is yours.
So thanks for organizing that. But before I speak, I would like to introduce the crew of our spaceship here. And so, okay, why don't you introduce yourself? 20 seconds each.
Hello, my name is Jack Laffey. I'm a third-year undergraduate student in Technical University Dublin, and I'm studying physics and data science.
Right. I'm Caitlin Robertson. I'm also a third year in physics with data science at TU Dublin, and recently I've been working on a spectroscopy project with Molly.
Hi, my name is Matthew. I'm also a third year student at TU Dublin, but I do medical physics with bioengineering.
Hi, my name is Álvaro Ropero. I'm a master's student in bioinformatics and biocomplexity.
Hi, my name is Marc. I'm a French student. I just finished my master in artificial intelligence and cybersecurity, and now I'm a research AI intern at Euromoon Mars, and I'm working with Jack on the project.
Hello, my name is Molly. I do physics technology, bachelor's, and I've been working with Caitlin on spectroscopy at the moment.
Hello, my name is Agnieszka Wartowska, and I am an engineer, a researcher, and analog astronaut from Poland. And currently prepare with Bernard simulation of the space mission in EXO Space Hub X Habitat. Yeah.
Excellent. And we have, of course, a few surprises for you later when all these young professionals are going to present and also describe their astronaut activities. Excellent. So, okay, so this works. Now I can start with my presentation. Okay, so, yes, please. Excellent. So now we are live, and we are starting with this overview So I put my first slide on. Do you see it? Wherever you are, on the Earth, Moon, Mars, or beyond. So we are here from our spaceship Big Business Innovation Center. And so I would like to present you some of our activities in the Moon, Mars research and workforce development. So it's a program we have developed with the LUNEX, that's a Society of Lunar Explorers, but also we have some Mars people with us. We have a Eurospace Sub, that is an academy where we have students from various universities in Europe. And we have also contribution, of course, from our Space Renaissance international members. So that's an activity where we try to develop some mission for space. We develop also some analysis of data. And now we are going to see how we apply some artificial intelligence to this data. And we have also development of some instruments. You'll see also some instrument talks for some of the students. We do field campaign as well in places that look like the Moon and Mars. And we develop as well some robotic system. We look at a human-robotic partnership. And at some stage, we want also to simulate how we are going to live in space station or in habitat on the Moon and Mars. For this, we have analog base we have used in Utah, in Hawaii. We also are going to EHTOS. We test some of our rovers and instruments, and we have developed also some simulation where some of the astronauts are being isolated that they would be on the Moon. Okay, again. Oh, sorry. So why did we start this program? We started this program, in fact, to support some space mission that we were building and launching at that time. So 20 years ago, we launched a mission to the Moon, Smart One. I was the father of this mission. The mother did all the work. I have to say, the mother was Giuseppe Ralca, the project manager. I was just the father and taking care of the science and the payload. We launched to the Moon a series of instruments. We mapped the Moon, we obtained various data, and we tested technologies for the future exploration. In particular, some of the technology that we had on board included some technology of spacecraft, some very effective solar cells, some onboard computer we inherited from automotive companies. We had also some intelligent battery system, and we had very miniaturized instruments, 6 instruments fitting in 20 kilograms. So we had a camera with a detector the size of a human eye. We had an infrared spectrometer, like a toaster, and we had also an X-ray spectrometer 10 times lighter than other type of planetary instruments flown on the mission. Also, we had various techniques of communicating with a laser link or with X-band high frequency, also some technique of onboard navigation. So these are the technology part also that we need to develop for future missions. But we have to start also by analyzing the data that we have obtained on previous lunar missions. Here's an example of the data we obtained with Smart One. We could measure tectonic wrinkles of the Moon, impact craters. We can also establish the chronology of bombardment of the Moon by counting craters. And we found also some areas where we have seen volcanism from 3 billion years ago and even from more recent time. We had a specific focus on studying the polar regions because that's the one we are going to explore. And we found also resources like water ice there. And we even made our impact experiment with our spacecraft at the end, and we could plan the impact and observation with astronomical observatory from Earth. With Smart One also, we made a travel map for future explorers that will explore the pole of the Moon. This is a mosaic actually, which was obtained by a master student working for a research project. She puts some 50 images together in a mosaic of the South Polar region, where you can see the Shackleton crater at the South Pole. There is an area toward the Earth, and an area toward the far side. Very interesting area, Amundsen crater where we found also some deposit of ice. And we also find very close to the South Pole a kind of a rich mountain region, which is high enough so that the sun is always mostly above the horizon, even during winter time. So we call it the smart one peak of light. And that's a place where many other countries or commercial landers want to go. And so we are going to establish a robotic village there, but also a human base at some stage. After smart one,
Bernard, sorry, I think we don't have your slides in full screen, and we are only seeing the first slide still.
Thank you for the feedback. Okay, so I'm going to stop share and I will put it again. Sorry about that. Yeah, thank you for. So I'm going to start again. Share screen. I have the slide. And now you see it's better.
No, actually, we see you zoomed in, but still we can see the slide, but this is just like before.
Yeah, but
so,
okay, you see the slide and the next slide.
Yes.
Okay. Okay.
Now we see it's in slide number 7, but if you can make it in a full screen, that will be better, of course.
Yes. So how do I do that? Why is that not? Ah, sorry, it was in this menu that was wrong. Thanks for the feed. Yes. Resume slideshow. Yeah, but the slideshow is automatic slideshow, no?
No, we can.
This doesn't okay here. Right here?
Yeah.
But it's automatic play, no?
No.
So, so I'm going to close the presentation and then we open it. Sorry. Now I'm going to share.
Okay.
Is it better now or?
We don't see it still.
So, because I have 2 presentations open. Oh. Note. So now you have this.
Yes, now we can see it in full screen.
To the next
It's
slide.
better now, but we can we can see the next animation or the next slides. So, but I think this is better, at least slides mode.
Sorry about that. Yeah, let's see. Okay, we'll go this way then. Sorry. And
Yeah, if you can't make it in a slideshow mode, then the best option now is to zoom in, I guess. But we would like to see the slides. I mean, we are now seeing the first slide. Can you change to the second slide to make sure that it's working? Yes. So if you zoom in for now.
You could maybe just to restrict to the left window. You should have a way to do it, to restrict the column on the left. Can you do it? If not, let's go in this way. Okay, it's good enough. Yeah.
Can you move this just down? I just need to click on it.
this one.
Yeah.
And this one, what?
Just move it on. There you go, it doesn't work.
Well,
It's up the top, so it's kind of high and behind this. Yeah.
At the bottom of the screen,
yeah.
there was a link to notes, and the fourth icon past that is the full screen option.
When I do, sorry, when I do the sharing?
No, on the presentation file.
Oh.
We were
I think
seeing the
they tried
presenter
it. I think
screen.
they tried it, but it's not working.
Really?
Yeah. Oh, yeah. Now we can see your screen.
That's it.
Okay, now I hope to find. I had several presentations open. Maybe that's a. I have to find out where the presentation is. It's not this one. Oh yes, it is. Okay, so we start again. I've lost it. So we had. Okay, so there's only one open, and I have to do the full screen. One. And this is not appearing. I have to redo.
You have to share again.
Yeah.
You're not
Share.
sharing. Okay, now yes.
Right.
Now you're sharing.
Now,
Slide.
where is that here?
Slide. Yeah.
Sure.
Mhm. Yes. Yeah. And we'll just check the third.
Still okay. Okay.
Oh, yeah. Okay.
Okay. Well, sorry, we'll go with this. Then you can see two slides at once. So, and let's see. Oh, okay. So this is what I've described. So our mission to the moon that we launched more than 20 years ago, and some of the technology that we had on board, so from spacecraft, but also for miniaturized instrument, and also some technology of communication, and onboard navigation. And what we can do with data that we have obtained in terms of studying the moon as a planetary object, looking at tectonics, impact craters, bombardment chronology, volcanism, and also polar regions that we mapped in particular, and the smart one impact that we observed from here. So this again, this mosaic was obtained with a master student analyzing some of the fresh data on the around the lunar South Pole, where we identified also places that we would want to explore that contain ice of the impermanent shadow, also places that are well illuminated for rover traverses or for human extravehicular activity. And indeed, we discovered the smart one reached a peak of light, where on an area of a few kilometers only, you could have almost permanent sunlight. So Smart One was alone at the moon for 3 years, but then we were joined by a fleet of other missions. In particular, we are sharing all our data with the world, and some of the Japanese that were preparing for Kaguya, a bigger mission, about 5 times the size of a Smart One. They made a very beautiful science and discoveries, for instance, on the gravity field of the moon, and also they detected lava tubes and other very interesting new phase of the moon. And we had also the Chinese that launched Chang'e 1. Yeah. So I hear somebody, maybe that's Celia. Can you mute yourself? Yeah, okay. Thank you. And so we had also some temperature map of the moon that was obtained by the Chinese mission, and we collaborated with those actually in a spirit of international cooperation, where we had some science support. We use our ground station from Europe to retrieve the data and to help in the navigation. And in the case of the Indian mission that was launched in 2008, we even put on board 3 European instruments. And then in 2009, we had a beautiful mission, Lunar Reconnaissance Orbiter, that was launched by NASA, and that is still alive and delivering data in various spectral range, but also images with a resolution of 25 centimeters. And we had also, together with LRO, the launch of EHTOS, so a big impactor that was plunged into the South Polar region and then could detect the existence of water ice in the subsurface for about 5% of composition. So in fact, 25 years ago, with the International Lunar Exploration Working Group, we proposed a roadmap for future exploration and utilization of the moon. In this roadmap, we start with this fleet of orbiters, then we have a phase with landers working in a coordinated way in a robotic village, and then we'll have a human for short duration mission, 6 days, and then a human outpost, and then a permanent base, sustainable, that where we'll have humanity permanently on the moon. So we have organized since about 25 years a series of community events, international conference on exploration of the moon, ISE sessions, a session at the European Geoscience Union, session with COSPA, and so the community is very well prepared, and we have also, for each of these events, issued some lunar declaration, where we look at all aspects, the science, the technology, the cooperation, the business, the resource exploitation, and also how we can use the moon as a way to build peace and also to train the next generation and even to prepare a space renaissance. So now what can we do also in practice, hands-on, to train the next generation of lunar or Mars explorers? We organize field campaign, and this was we started in 2009 with the Human Mars program, where every year we send some researchers in a moon or Mars base for 2 weeks, and they do laboratory research, field research. they demonstrate some instruments like cameras, rovers, drone. They also validate some technologies of habitat and how we can support life. And also they go there in an international crew and look at all the aspects of human performance, EVA activities, living, medical aspect, food, and so on. And it's a great opportunity for training young and advanced researchers together from different countries and also to communicate that to the public. So we use a base at the Utah Mars Desert Research Station. You can see that there's a laboratory, there's a telescope, a dome, and we have also a facility now in Hawaii that is run by the International Moon Base Alliance. So, for instance, we organize as well some outside activities with rovers. We made some EVA with astronauts with a ground penetrating radar, making drills, taking samples. So, de facto, we are trying to prepare a program, and this goes very well in line with the current program Artemis, that is led by the US, but with a strong contribution from Europe. The US is developing this Orion capsule for 4 astronauts, a kind of Apollo on steroid, and that will bring 4 astronauts around the moon. But they cannot go on their own, the US. They needed to have the European service module that brings them as a fuel, as also the equipment and the navigation and all the control that allows this capsule to go around the moon and then to return to Earth with excellent precision so they can re-enter in the atmosphere. So we have launched already Artemis 1 in the mode of automatic, so empty of astronauts, but with a lot of sensors and equipment. It worked well. And we are preparing now for Artemis 2, where we'll have 4 astronauts going around the moon for about 5-6 days. And then we'll have Artemis 3, where there will be also astronauts going in this kind of halo orbit. And from there, there will be a human lander that will bring 2 astronauts to the surface of the moon. And the plan is to have the first women on the moon at this stage, on the surface of the moon. So this is how the Orion plus European Space Module look like. Now, concerning Artemis, we have identified a number of specific regions near the South Pole which are of interest, scientifically from the resource point of view for future exploration. And then I've put some of this Artemis candidate region on top of this map that we had obtained some 30 years ago with my student. And you see what we have done in the past is very useful to prepare the future. So after this yearly mission, so at the moment, you know, there is in the Artemis program, there will be a human lander that is built by SpaceX, Starship, and there is another lander that is built by Blue Origin, Bezos' company. But every year we'll have a series of missions, and at some stage we'll have a base camp where we will go from mission lasting only 6.5 days to months, and possibly we will have long duration mission where the astronaut will rotate and will have a permanent human presence on the moon. So how can we prepare for that? So we have also had this vision in Europe for this moon village that we called from our mission to be not only for scientists or engineers or space industry, but should be for all. And then we developed this mission of Moon Village, where you can share some of the benefits of knowledge, new technologies, business opportunities, jobs, training, space renaissance. And now we look, how can we involve people in this preparation for the Moon Village? The one aspect is to get there with rocket, with lander. It's very hard to land softly on the moon. So recent robotic mission had some mishaps. So this will lead to the rocket scientists. So there are some companies and a number of actors that are trying to develop the launchers and the lander on the moon. But for us also, we are looking at how to optimize the design of habitat, of laboratories, communication system, both native communication on the moon, but also with the Earth, the operation, energy management, also survival of astronauts, of equipment, life support system, and mobility with robotic system, but also mobility with the pressurized vehicle with astronauts. So clearly, we are looking also at the best partnership between human and robot on the moon, but also many humans will be on Earth, teleoperating a number of rovers. I hope very soon I will have my own avatar on the moon. Each of you can have your avatar, and you can see through the eyes and manipulate through the arm of your avatar on the moon. And so we'll have a lot of teleoperations for the moon. That is possible for the moon. That's not possible for Mars. It has to be more autonomous for Mars. We will also exploit resources on the moon, like ice, like the regolith for construction, like metal we can extract in the future, even helium-3 for clean nuclear fuel. But the novelty is that this will be done not only by government agencies, it will be done by a collaboration also with new partners, terrestrial industry, new space industries, entrepreneurs. So the whole population, society can be involved. So in our program that we have started like 15 years ago, Your Moon Mars, but we expand with many partners, we put some emphasis on some research activity in the area of data, analysis of space mission data, in particular using some new tools of AI machine learning. So we will hear Mark and Jack talking about it. Some development of instrument or testing instrument that you use on future mission, like spectrometer. So you will have Caitlin and Molly talking about it. Some robotics, Matthew will talk about it. Lab support system, biology experiment, Alvaro will talk about it. Energy and so on, and also operation. And we have also our astronaut ready for flight. Agnieszka is ready to be launched. So also we are looking at how you can implement space mission project, the financing, the stakeholders, and the project management. And we look also at materials that can be exploited on the moon, power, and manufacturing on the moon. For this, we organize also a number of laboratory activities and also analog field campaign where we test on the system like we would be on the moon and Mars. And clearly, all this requires a strong effort of training, of resource capacity building, so workforce development, which is the topic of today. But we want also to do that together with the business part. And for this reason, we are here in the Space Business Innovation Center of near ESTEC, and we talk with business people, people with models, people with ideas, or people which are acting, which are doing things to establish some research activity that could be funded and can lead to the next step. Now, as we mentioned, a very important dimension is peace. So how we cooperate peacefully, how we build peace by working together in space. And we want also to include some broad humanistic aspect, even philosophy, culture, art, because we want to bring the whole society to benefit from exploration. So, in a word, space for all is what we want to do. So, back to technology, we also try to do hands-on activities. So we built at the time of a Google Lunar X Prize competition, a small lander together with a company that was in the competition, together with iSpace that was building a rover. And we tested some cooperative robotics between two robots and a lander. We tested them, some of them at ESTEC. You can see the small iSpace that put a rover, and with other partners, like for instance, here in Luxembourg. You have seen, we even went to the moon and we landed a package to the moon. And from there, we deployed a camera, we deploy a rover, we go fetch samples, we analyze it with a spectrometer, and then we know what it's made of. So the rover was working very well, down slope. We had difficulty going up, so that's me. And so we went around, and actually this was a very nice campaign organized in times of COVID, where we met for the first time on the volcano at So, okay, we repeat, but eventually The year after, in June 2022, we had a very gigantic campaign organized by the German Aerospace Center and ESA, where you had 70 people. We had 3 intelligent rovers. One rover was operated by an astronaut, Thomas Reiter, and we deployed some 15 box payloads on the surface of the moon. And yes, you have some also additional demo rovers that joined the family for test. And we had experiment analyzing sample, also making radio observations, and as well navigation. So de facto, this year is International Lunar Year. You have seen we have got many missions launched to the moon. SLIM has arrived. We had the intuitive machine 1 Nova C Odysseus lander also has arrived. So here it's represented vertical. In fact, it's more, it landed horizontally. Both of them were a bit horizontal, but they were successfully landing softly. And actually, we are preparing also a series of other landers. And one piece of news is that I have joined since a few weeks the team of Cosmosis, a company that is planning to launch a lunar lander in 2028. And I'm looking for very smart payload. So if you have some ideas, come talk to us. We are trying to prepare some, and there will be some for industry, there will be some for university, there will be also some from young professionals. So the challenge is with you. We have done some tests actually of operation between astronaut and lander. So this was with the Austrian Space Forum. We had an astronaut maintaining, repairing some of our landers. And we had also access during some of our campaign to a laboratory that was in the habitat where we use instrument, X-ray, visible, infrared, shooting Raman, laser beam, microscopy to analyze some samples. And this is in preparation and support of future mission to the moon and Mars. And that's also an activity that we are continuing here. You will hear Caitlin and Molly talking about sample analysis. So we have this laboratory in a habitat. We are building an habitat also where we have some of these experiments, and we want also to have a package that could be put on a rover, a bit miniaturized. We also developed some precursor experiment. We call it ExoHub, where we built a kind of lunar laboratory where I locked my students for 1 or 2 days. And they had, but they had joystick to operate rovers. They had a spectrometer to analyze samples. They had also 3D printers. So if you forgot something at home, you didn't need to wait 5 days to bring it from Earth. And they had also a little rest area, but they didn't rest so much, I would say. So they had a very full program. The Artemis astronaut will be 6.5 days, very active schedule. We have also a program called Moon Mars Poland, MPOL, where we locked the researcher for 1 week in a base without window, without time. And then they work on a very intensive program. So here you can see the capsule communicator, Capcom. They use virtual reality. They repair experiments. They grow plants in the base. They also did some emergency rescue practice. And, oops, sorry, that was a bit too fast. They also do some technology measurements, some physiology measurement, reflex on the moon. And they even invented a kind of hammock for the moon that they tested to rest and meditate. And they do their 1 hour exercise per day to fight against bone loss and muscle. So this is in Poland. We have also 1 base in Hawaii, I'll describe later. But we have thought also, let's bring the moon base to all. So we built together with my former student, Ersiana Croti, a portable moon base that can go around. So it has a laboratory module and a rest area, some scientific racks. So that's how it looked when we just built it. Now it's full of experiments. So it looks messy as a space station now, but we are using it for tests. And it's a bit small. And so for this reason, we have added a part that tripled the total volume. So with inflatable module that serves also for extracurricular activity preparation, also for outreach. So we tested that outside the SBIC, Space Business Innovation Center, but we also now we have it in Leiden. So that's how you prepare some of the experiments close to your lab. But after, you have to really go to the real Moon and Mars environment. For this, we go to extreme places like Etna volcano, Utah desert, Atacama, Iceland, and also we have now a base in Hawaii, in Mauna Loa volcano, where we can test some astronaut activities. So that's IC's base. It's fully sustainable in terms of energy, and it's surrounded by a beautiful landscape of volcano very similar to the Moon and Mars. So we have really operated this since 2018. And so we had some 10 missions of a duration of 2 weeks using it. And more recently, we had also a number of students, master geology students, analyzing samples from the Moon and Mars. But last year, we had a gigantic eruption on Mauna Loa caldera upwards, and you had 2 flows of lava on each side of the habitat, but we survived because it's high enough. But eventually, we went there in February last year with an expedition led by our commander, Hank Rogers, but I was a scientist on board. We had Celia as our psychologist, we had Serena Croti, and we had Kato Kless, who is now the director of operation for the base. So we have all these activities indeed that can be used to train young professionals and not so young professionals. It's open to all for space research, astronautic. But now we have integrated this in a curriculum called Eurospace Sub Academy, where all these various expense can be validated, be put in your portfolio, and this is open to all of you, all age that want to take some of these modules. So we have this module of physical elemental training of astronauts, but we have also some space science lecture, technical lectures. We have also added a pillar on humanities and social science. Really, it's very important to include, and also a pillar on management, business, looking for funds, communicating, and data management. So you are all welcome to take some of these modules or to join some of our field campaign where we organize this activity. As an example, for instance, last year, 2023, we had some 12 interns for 10 months that work on various topics, Moon, Mars, spectroscopy, astrobiology, economy, diplomacy, architecture, very diverse. And this year cohort is also very diverse, as you will see. And so we have also a system of special grants of some special project manager where we give some support for half-time service activities in parallel to research activity. So also one dimension that we have tried to add is art, and we developed 10 years ago a project of the Moon Gallery and a series of art Moon Mars activities. So we designed a gallery of art with 100 pieces of art that we could send to the moon. We make exhibition in many places on Earth, and we even built a gallery of 64 art pieces that we flew to the International Space Station for 1 year. And you can see it in the cupola. So in the last 2 years, we got also some nice funding from the European Commission in the area of business for space. So I got the money, I accepted the money, but I added research and astronautics. So now we train together people to do research, astronautics, and business within this fund. And we try to share this knowledge in various events, like we went to the International Astronautical Federation IAC meeting in Baku this year with a great technical content, great networking, collaboration project, and also big cultural aspect. And now we have in Space Business Innovation Center our own office. So our office is your office. When you come to by, don't hesitate to pass by and use our office. We use it also for space renaissance activities or Eurospace Hub. And so we have our workshops here, and you can use our best. We even do astronomy from Holland, you know, believe it. And we go also in some events with our Space Campus Netherlands, which is federating all activities of space industry, universities, and startups in the Netherlands. We have also a strong contribution from our colleagues from Toulouse. So in Toulouse, I'm giving a class of space system design and propulsion. So I've got 40 students last year. They made beautiful design of a space mission. They are also strong contributors to our MPOL program. And we are going to visit them in Toulouse. So we'll have a delegation from Netherlands going to join our Toulouse colleagues. We also participated to the Space Tech in Bremen, very good place to meet some of the industry in Europe involved in space. And we have good partners in various places, particularly in Toulouse. And we have also very strong contribution from TU Dublin. So we have a special contingent of TU Dublin physicists, biomedical engineers, or scientists that are part of our cohort here. Strong collaboration also with Poland. We have our Poland astronaut with us, with France as well. We have Spain with us. So we are, and we will have more Italians, of course, and other countries involved. So let's now, before I give the floor to the young professional, talk about the plan of activities for this year. So we have just got a very nice workshop. We had an event at ESTEC also about inspiration and exploration. We have got our new contingent of Your Space Up Academy. We have some activities we will present at a large planetary conference like in Houston or in Vienna. In May, we are going to organize a road trip with all the astronauts, researchers, and also even our habitat. We spent some time in France, near Clermont-Ferrand, Plo, in the volcano region. We go to Toulouse. And then we are also planning a nice field school of astrobiology in Vulcano, so near north of Sicily, in the Aeolian Island. And we present some of the results after at CROSPAR and at the International Astronomical Congress in Milano. So, in a summary, this is our program for the year. Now, I would like to invite the cohort of Your Space Academy, Your Moon Mars, to give you a snapshot of their research and how they develop as a workforce. Thank you for your attention. So I pass on the button. Ah, yeah. Okay. So I stop sharing. And we have a nice choreography of a presentation that has been coordinated by the students themselves. So you are now in charge.
Thank you very much, Bernard, for your presentation.
And now, so on various elements, we have data analysis, instrument, field test, astronaut and habitat. So we'll go a bit in this order. We start with Jack and Mark on machine learning applied to space development.
Sorry.
So as I understood now, you're giving the floor to your students to their presentation, right?
Yes, 4 minutes each.
4 minutes. Okay, start the timer. Hello, I'm Jack. I would like to talk about machine learning applied to Earth observational data. Oh, is that changing for?
Yeah.
It is. Okay. Okay, so yeah, so you're seeing the right thing. Perfect. So I want to talk about machine learning applied to Earth observational data. I just want to give a general overview. Some of the reasons that we should be really excited about this, very powerful tool that can be used in all sorts of ways. And then afterward, I'm going to defer to Mark. Mark is going to talk more about the research that we're doing and really hone in. Now, so 4 headings that I want to talk about today: disaster risk, urban planning, energy sector, and environmental reasons. So I'll just go through. Now, of the headings, this one is already the most well utilized. In Europe, we have a few initiatives. I think we have 4 or 5 initiatives that use Earth observation data to track any anomalies, high-risk areas, forest fires, flooding, similar things like that. Mainly the Copernicus constellation and our neighbors, the Galileo constellation, are what we use here. And then in North America, they mainly use Landsat, and they also use Copernicus. So this is very okay. Well utilized already, but there are some technologies like they're trying to develop trying to use machine learning techniques to identify areas that are likely to be trapped, which could mean a difference of days or hours, and it could save someone's life. And this is also could be very powerful combined with social media post analysis, which is a high quality source of real-time data that is often overlooked. Now, urban planning and infrastructure. This is going to be the focus of my next project. So what we would like to do is we want to see trends and growth and try to predict if there's going to be any kind of population boom or what kind of infrastructure we're going to need in the future. So we'd also like to look at traffic patterns. Not quite as relevant here in the Netherlands. It's already quite good, the infrastructure. But in other countries like Ireland, where I'm from, very old, very, very old cities with very bad traffic, very bad public transport, which also ties into climate because it means. Excuse me? I don't know. Just need to mute.
It takes a team of astronauts.
Okay. I'm not echoing now, am I? I am.
Oh, it's because of the answer to the projector or something.
Okay. Can we mute the projector? Okay. All right. Okay. Everything is still okay on everyone else's end, I'm going to assume. Okay, so traffic, and then also we would like to take an angle of tackling social inequality and building amenities, which again, this also ties into climate, because when you have more of these sort of public spaces like parks, more vegetation and green cover means that means with cooler cities, so less energy spent on air conditioning. Energy sector, smart cities. I've talked a little bit about this already. This is one of the more straightforward ones where we're using electricity where we don't need to. Waste management, all sorts of things, just optimization problems. Similar things I just talked about: green cover, water bodies, and also analyzing weather patterns to see for renewable sources of energy like wind turbines and solar. We want to see where we can push them to get as much energy as possible. So we want optimal placement. Environmental compliance and regulation. Won't talk too much more. I've mentioned it a few times now. Mark will talk a little bit more about it, about vegetation in cities. So I'll actually hand off to him now. He'll talk a bit more specifically about what we're studying. And yeah, thank you very much for your attention.
Hello. Okay.
Okay, so hi, I'm Mark. So I'm working with Jack. So our project, like we noticed that this last years, like it has been like really unbearable to live in the cities during the summer because we had to face like really hot period, like a lot of heat waves and the lack of temperature regulation. And so that's why we wanted to work on a sustainable way to organize the urban growth. So like the thing is that it is inevitable that cities are growing, but our aim is like to use machine learning and Earth observation like to go on a sustainable way of growing. So that's why we first like want to use some neural network models, so like CNN, convolutional ones, to detect the cities, as we can see in the example. So the idea is to detect the city, use some image segmentation to like analyze like how it was growing, but also the repartition, like the proportion of vegetation in it and the water points, water bodies. And also with that, we want to use like the combination of frequency bands from Sentinel-1. Sorry, it was the data from Sentinel-1. So we want to use the combination of frequency to be sure like our analysis is good, so like to be more accurate, because we know that this will like ensure that our neural network models is good. And then we want to use like to gather this information with the data from Landsat 8, which give us like the ground temperature. And so with that, we can understand like which points are like really hot and like understand how it's correlated to the green spaces in the cities. So like the idea is that to understand the patterns and also the strategical hot points, so we can like implement their like new green spaces to try to cool them. So like our ideal goal is also, sorry, is also like to understand and take example of like the greener cities we know, like for example, yeah, I took Singapore, but like it's also the case of some areas in Dubai or things like that. And so we want to understand like their patterns, how they organize the cities to try to be cooler, to be more fresh. And also we want then understand this, learn about it, and so we can like try to give some advice on all the cities worldwide to like help them to grow in a sustainable way. So our solution would be virtuous because like on one way we will like regulate the temperature during the summer. So it will also reduce the use of cooling systems such as ACs and fans and things like that, which are like a major part of electricity consumptions during the summer. But also with implementing new green spaces, we will reduce the air pollution, but also we will avoid some flood disaster in cities because we will like give more soils to absorb the water, and also we will give a better quality of life for our citizens. Thank you for listening. This was our project with Jack.
Right. Hello. As I said earlier, my name is Caitlin, and I'm going to talk a bit about the project me and Molly are doing at Leiden University at the moment. Yeah. Okay. I'm going to introduce the instruments we've been using, or well, the instrument we've been using, which is the hyperspectral camera shown on the screen. It's it's very similar to a normal camera, which you see up on the top left, you see how a normal RGB camera would take an image, which essentially only has 3 wavelength bands, and it makes a very small 3-page book. So the camera we're using can take from 400 nanometers to 1,000 nanometers. For each of those wavelengths would be a page in that same book to create an image of our material. Sorry. So it has a lot of uses between for vegetation and agricultural use, because it's practically live imaging. It can be used to detect how healthy your plants and vegetation is. So you can identify any thicknesses in your plants when the spectrum varies from the healthy state. And in food quality in factories, along the conveyor belts at the end, you can analyze consistency and identify any defects. So any contaminants in packaging or the final product can be detected before it's sent out and can be removed from the production line. It can also be used in the separation of waste in recycling facilities or any sort of waste management, because it can identify the different materials through their spectrum. And then for me and Molly, the most interesting is the material identification and analysis, because each material has a spectrum unique to itself. Like humans have fingerprints, each material has a separate spectrum. So when you have live updates on what material is passing by, you can very quickly scan an area for any unique identifiers. Molly will talk a bit more about how we're using this in our project, if she wants to now. Yeah. Thank you.
Hello. So again, Molly. I'm doing my bachelor's in physics technology, and as Peyton said, I'm working around a spectrometry project. Yeah. So I have 2 research goals while I'm here at Europe in Mars. It is to conduct spectrometry on the analog lunar samples, but to also create maps mapping the moon, and to locate places of interest for developing a lunar base in the future. Yeah. So this is our spectroscopy project so far. At the top there, you can see some igneous rocks that we took samples of that resemble the Mare basalts, and then also the finer grain samples. In particular, we took samples of pyrocene, which makes up about 60% of lunar regolith. And at the bottom there, you can see we did capture clear images, and you can see the different intensities in the spectra at different locations on the sample. Sorry, yeah, so the next step then would be to use the spectrometer in combination with a telescope to take a spectral image of the moon and analyze that, which has been hard to do because the sky has not been clear recently. But yeah, hopefully soon we'll be able to do that. And to use the analog samples that we have taken and analyzed and create a database that could be used as a reference for on-site lunar spectrometry. And then so yeah, the second part of my project is going to be locating lunar base sites. I'll be doing that by researching the topography and mineral distribution of the moon through satellite data taken already and previous sample analysis. Yeah, and it is important to find a location that supports a self-sufficient and sustainable habitat. A few criteria that I'll be looking out for is the accessibility of natural resources in that area, for sustaining life, hydrogen and oxygen water, looking out for the abundance of native minerals to hopefully utilize on the base, and features on the moon of scientific interest, so volcanic regions, regolith processes, and impact sites to analyze. And access to solar power is very important to try get constant solar power, minimal temperature fluctuation, and to ensure communication could still be possible with Earth and not blocked by the moon itself. And it would also be good if there was observational opportunities into future space from that location. So yeah, thank you.
Then we have our engineer on board, dealing with rovers and sensors. Matthew.
Hello, my name is Matthew, as you just heard. I do medical physics and bioengineering. So I want to talk to you about the rover experiments that we're going to be doing here at Moon Mars. The rover that we're going to use is a ICAR Pro. It's a small rover with a robot arm. The main reason we chose this rover is it's very accessible and a lot of people have used it. So there's a lot of programming out there already. And the other reason is that it's very modular. So you can put together different parts, or you can 3D print extra parts if you need them. What experiments are we planning to run? The rover gathering samples. As you know, the main purpose of rovers up until now has been to explore and to gather samples. So using the robot arm, we're going to attempt to retrieve samples and then spectrally analyze them back to the lab. We're going to use it as a navigation companion. So we're going to have one of our analog astronauts here have limited vision, and then we are going to try and lead them back to the hab safely, using only a little light on the rover while one person is remotely controlling it. And finally, we want to integrate solar power into our lab. So we are going to buy some solar panels, and hopefully we can charge the lithium-ion battery with them so that it's fully sustainable. And additionally, I'm working on my own project as well, which is focused on the medical data, or the medical data and biomedical sensors that we're going to use on the astronauts. It's very important to medically monitor the astronauts that are on isolated missions. So I'm focusing on doing that. I'm going to use smartwatches, and if necessary, I'm going to build my own small project with an infrared light to measure the heartbeat of the astronauts myself. And the experiments that I'm going to run, I'm going to monitor the sleep quality of the astronauts under different lighting arrangements. I'm going to use VR equipment as a replacement for traditional exercise. I'm going to integrate all of that with a Python script so that I can automatically record all of the data that we take. And that's it. Thank you.
So we are rovers, but now we are transiting towards the moon base. And for this, we need to develop also some biology research, some lab support system. And we have Alvaro with us that we describe the experiment.
Hello there. It's on the left one or the right one? The right one. Yeah. All right. So my name is Alvaro Ropero. I'm a biologist, and I'm currently involved in various projects Partly, I am in charge of the science communications in EuroMoon Mars, and my presentation was tailored mainly about how to communicate and what we are communicating to whom. Also, part of that is an experiment that we are carrying out currently in collaboration with the Spring Institute, which is a volunteer-based research organization that I'm also part of. And with this project, we're working with lunar regolith, and we like the moon. We like to go to the moon, but plants don't really like the moon. I'll be very brief about this. Plants that have been grown on lunar regolith and lunar regolith simulants show a lot of signs of stress, and they simply won't grow enough to provide crops and an agricultural base to sustain a long-time human habitat. So we know that they don't like lunar regolith, but they do like earth soil, right? So there has to be a sweet spot in between where plants may tolerate the harsh condition of the lunar regolith. In our experiment from the Spring Institute, we are doing some data-driven hardcore science experiment at the University of Arizona, and that's collaborating with EuroMoon Mars, because we are in the habitat, the portable habitat that Bernard described before. We're doing a little demonstrator of that experiment, essentially a set of closed ecosystems with the lunar regolith simulants on some plants, mixed with organic matter from different sorts, different types of organic matter. And this is aimed to show where exactly, in which point of this gradient of regolith to organic matter, plants will grow in the best way. Mainly, this also serves as an outreach asset. It's a very good example, very minimalistic setup to bring to schools, to bring to high schools, to bring to universities, that they can also replicate themselves. It's also rather inexpensive, except for the lunar regolith, but still overall, it's very affordable. And our secondary goal is to increase the inspirational value of these sort of experiments. And now I'm gonna give the floor to Bernard again.
Okay, thank you, Armando. And last but not least, we got an astronaut that just landed today on our planet. So that's Agnieszka Edwiartowska, and she's going to present some of the experiment that she's conducting. So maybe we can go back we can remove your presentation. Yeah. So, Agnieszka.
Okay. Hello, everyone.
Show you all.
Okay. So, hello, everyone. My name is Agnieszka Edwiartowska, and as Bernard said, I'm from Poland. And I am an engineer, researcher, and analog astronaut. Like, I participated in a few analog missions. For example, I participated in the very first Chile's mission on Iceland, or the first Polish-Brazilian mission in Habitat Marti in Brazil. Today, as I didn't expect that I will present anything, maybe I will shortly tell you how simulations of space missions can actually really improve real space missions. For example, my friend from Sport University in Gdańsk, Professor Marcin Dornowski, greetings Marcin, invited me to a project connected with neurofeedback EEG, which purpose is to reduce stress. And we performed this experiment in 2021 during 2 analog missions in one of the Polish simulations base habitats in Habitat in Poland. And actually, during even if there was an isolation, because this experiment was never performed in environment like this, so there was an isolation, 2 weeks isolation without you know, like in Polish habitats, there's no access to the sun and etc. And actually, neurofeedback EEGs was quite successful in stress reduction. So we wrote paper which we published for EAC, International Aeronautical Congress, in 2022. We published our results, and last year in 2023, there was amazing chance there was a call made by European Space Agency and Polish Space Agency for application for experiments for International Space Station, and me and Marcin applied with this experiment with neurofeedback EEG, and actually it will probably go to International Space Station in 2024 with a Polish astronaut in probably Axiom 4 mission. I said probably because ESA told us it's not like confirmed until we sign agreements, but generally ESA agreed, and we are waiting for a NASA agreement to send it on International Space Station. Okay, so actually, this is a proof. This is great proof that simulations of space missions make sense, and they can have real impact of for real space missions. I will only explain shortly what is neurofeedback EEG. This is for example, during simulation of space mission in which I participated, and I had to perform this experiment I had to put electrodes like on the head of each astronaut. There was some pain, okay, on this. It was painful. I had to put electrodes which were connected to EEG module and to the computer, and by using proper brain waves, there was an animation on the computer. And by using proper brain waves, participants of this mission, I mean control group, because of course astronauts were divided to the control group and to the control group and the test group. The test group had to perform this experiment. They had to move by these brain waves. They had to move animation, which was switched on the computer, by proper brain waves. And this is how relaxation appears. Okay, so yeah, thank you very much.
Okay, so that's conclude our set of presentation. Now, if you have some questions, if there are some volunteers to join our group, yeah, you are welcome. I think we still have 15 minutes from the 1 hour and a half we had planned. But if you have some questions, we are happy to answer.
Thank you, Bernard. Of course, this is an amazing team, very diverse. Before I give the floor to Adriano and everyone, I would like to remind also your team that we are open for applications. If you like to join to work on an O'Neill cylinder to host hundreds of inhabitants as a team, of course, we are open for your application. So Adriano, do you like to say something?
You anticipated me because I just wanted to say exactly the same thing. That
okay, so there is a call for ideas. How to host 100 people in a cylinder in space. Yes.
So this webinar series is in preparation of our workshop that we are calling young researchers and students to team together and participate to the workshop that will be held in September. The workshop will take 2 weeks, or better, we will have the first day, at the beginning of September, the second day in the 1 week later, and the last day 2 weeks later. In the first day, we will give to the participants a statement of work. We are simulating, we are impersonating a space agency calling for tenders. And the team, the competitors team, will be the participants to the tender. So they will have to present a proposal, technical proposal and management proposal and everything. Okay, everything will be detailed better in the first day. Okay. However, keep in mind that we will give you a statement of work that with the requirements of what you have to develop as a proposal project for an on-air habitat, rotating habitat in a Lagrange point. This is the idea, and we would like very much to have innovative ideas from young researchers as you are. So you will be very, very welcome to participate. I will give in the chat the link to the registration form. So if you want to register, you are very welcome to register right now. Ganim?
So big challenge. So in terms of involving all our friend community here, so we have also the abstract for the International Cycle Congress. They will do tomorrow, but okay, there is a 1 week extra time. So you can say, please submit abstract for IAC, for the banner session. I organize a session, dinner session, but there are many other sessions of interest. Each student today is submitting 1 abstract as per tutor with the collaborators. So that's a good thing, and we see many of them at IAC. I want also to advertise another event. We have a COSPA, Committee for Space Research in Korea, in Busan in July. And also we have got a number of abstracts submitted. Now, also on 20th of July, we are celebrating International Moon Day, an initiative that is worldwide, which was developed also by Moon Village Association. And there is a competition for groups that are designing a moon base 2050. And there are various prizes. I think the top is at $5,000, $3,000. And there's a possibility to present some of the results in Nanjing, in China, on the 20th of July. So it will be nice. There are a few Chinese teams. There are also a few worldwide teams. Could be also Space Renaissance Young Professional Team, I would propose. So let's form a Space Renaissance Young Professional Team with a mixture of some of you that are attending. It was a webinar, some of you here. And let's have a Space Renaissance team designing moon base for 2050. And I would be also, I would have a possibility to do some co-funding for those that are participating to this competition.
Excellent.
Thank you, Bernard. I forgot to say that the winner team will get a scholarship. Maybe Ganim said it in the beginning of this webinar today. However, it's worth to repeat it. The winner team of our workshop will get a scholarship to participate to the IAC 2025 in Sydney, Australia. And yeah, we could have other interesting things that could come up after the workshop, as the possibility maybe to present the winning project to ESA, to the European Space Agency, and other things. This is all a work in progress. Okay, so I cannot promise anything, but the sure thing is that they will get a scholarship by now, but we can have more. And last but not least, I also added in the chat the link to register as members to Space Renaissance International. We are an activist organization. We survive over the membership fees of our members. The membership fee is very low, and for students is even is half, is a few euros per year. So you have the link over there, and I hope to welcome on board all of you. Thank you very much. Guys.
Excellent. It's also, of course, a great asset to a lot of information. There are some committee activities of Space Renaissance. There are events. There is also a fund for young professionals, a very cheap fund that can support some of the projects. So really, join Space Renaissance International.
Excellent. Any other question from the audience or maybe a comment?
Question from you?
If not, then I guess this is the end of our discussion today. So again, thank you, Bernard, and thank you for the team. And looking forward for the results of your presentations in IAC next October. Yes. Bernard, do you like to say a final word?
Yeah, so again, thank you, Karim and Danilo, for organizing this series of webinar. And so the audience is really towards the young generation. And I want to thank here, so Mark, Kathleen, Mark, Kathleen, Molly, Alvaro, what happened? Matthew, Alexia, and Mark. Okay, all the best. You are still? Yeah. Okay. So
thank you very much.
Thank you, everybody.
Bye.
Thank you.
Rotate back to
Astra.
Let's see you.
Goodbye.
So thank you. Thank you very much.
Bye bye.
Bye.